Hi, this is King of Review. So here we have two graphs. One of our graphs is a reflection of y equals log base 2 of x over the x-axis. Let's think about that for a minute. If we have a graph here of any function, and we reflect our function over the x-axis, what was below the x-axis moves up, and what was above the x-axis moves down. So basically, what reflecting over the x-axis does is turns negatives positive and turns positives negative, since the positives have moved down to the negative part of the graph and the negatives have moved to the positive part of the graph. So when we say that we've reflected y equals log base 2 of x over the x-axis, really what we're saying is we have turned it into negative log base 2 of x. Now the other graph is shifted m units to the right from the same graph, y equals log base 2 of x. Well, when you shift a function to the right, any function, if you want to shift it to the right, the way to shift it to the right by any number of units, by m units, is to subtract m from x inside the function. So in this case, if we're shifting m units to the right, this means that our function will be the log base 2 of x minus m. Subtracting m units inside the log function will shift this graph m units to the right. Now we're told they meet at a point on the line x equals 2. If they meet, that means the two y values are equal, so we can set these two equal to each other. Now we can almost get rid of the log base 2 on both sides, but we have to get rid of this negative in front of the log. This is really a negative 1 multiplied by the log base 2 of x. And there's a property of logs that if you have a number a multiplied by the log base b of some number x, we can take that number and move it inside the log as an exponent, turning this into the log base b of x to the power a. Using that property, I can rewrite the left side of this equation as the log base 2 of x to the negative 1, and that's still equal to the log base 2 of x minus m. Now, since both sides are the log base 2 of something, I can essentially cancel out the log base 2 on both sides. And now I have x to the negative 1, which is the same thing as 1 over x. And on the right side I have x minus m. Now m is what we're trying to figure out, but we know that the point where these two meet is on the line x equals 2, meaning I should be able to plug 2 in for x in my equation to find this point where they meet. So this equation turns into then 1 over 2 equals 2 minus m. And now this is a simple algebra problem to solve. If we subtract 2 on both sides, we get 1/2 minus 2 is negative 3/2, and that equals negative m. If we divide both sides by negative 1 to get rid of the negative signs on the right, we get our final answer of m equals positive 3/2. But remember, we wanted to find 2m, not just m. Well, that's easy enough. If we want to find 2m, that's just going to be 2 times 3 over 2. The 2's cancel out, and we are left with 3 as our answer for 2m. And that's it. Thanks for watching.